my beautiful learners. Tshaka, your physical science educator from the ETSA Educational Project Center of Distinctions. So for today, I'm going to take you through the question paper. The topic that I'm going to focus on today is this one of Newton's law. So I'm going to do the exam type questions as to prepare you for your final examination. So please, my beautiful learners, be in a position of having the calculator with you as you're about to do a lot of calculations. What I normally tell my learners is that one Newton's law, it starts here in grade 11, and then obviously when you are doing well in Newton's law, my beautiful learners, you are one step out of poverty, because even when you get to grade 12, you will still be busy with Newton's law. The Newton's law that we are doing here in grade 11 is the same as that one that you will be doing when you get to grade 12. Hence I'm saying that when you master this topic, you are one step out of poverty. So let's start. We are having question 4. In the diagram below, a 2 kg block is connected to 1 kg block by means of light inaccessible string. The blocks are pulled up an incline which forms an angle of 28 degrees to the horizontal. The sides of the block which touch the inclined plane have the same area. Okay, so meaning we are provided with 2 blocks. As you can see, we are having the 2 kg block that is connected to 1 kg block. So meaning the type of force that we are having between 2 kg block and 1 kg block is the tension force. And then on 1 kg block we are having the force applied, of which the magnitude of our F applied in this situation is 30 Newton up the incline. And then the angle that is given on our diagram is 28 degrees. That is the angle that is provided. Okay, so now the kinetic frictional force between the 1 kg block and the inclined plane is 4 Newton. Meaning the frictional force for 1 kg block is 4 Newton. Please, on your notes, you can just write them down so that you can remember. The kinetic frictional force between the 1 kg block and the inclined plane is 4 Newton, while the kinetic frictional force between the 2 kg block and the incline is 8 Newton. So we must also remember the frictional force is a force that opposes the motion of an object. Since our blocks, block 1 kg and 2 kg, are moving up the incline, meaning the frictional force is opposing the motion of those blocks, meaning the frictional force is opposing the motion. That simply means that the frictional force is moving down the incline. So if the object are moving up the incline, the frictional force is facing down the incline. Okay, and then 4.1.1 for 5 marks, draw a labeled free body diagram showing all the forces acting on 1 kg block. My beautiful learners, if the marks that are allocated on the question is 5, that simply tells us that the types of forces that we must draw for 1 kg block, they must be 5, because the marks that are allocated on that question is 5 marks. Okay, so now 4.1.1, here is my surface. My surface is like this. Let me draw my object. Force number 1 that I have there is F applied, and then force number 2 is our normal force. Please, my beautiful learners, remember that the normal force must be perpendicular to the surface, meaning when you draw the normal force, it must form an angle of 90 degrees to the horizontal. So please make sure that you get this one right. And then number 3, I must also have Fg, which is our weight. And then number 4, let me have my tension. For 1 kg block, the tension is facing downwards. So here is my tension. And then how many forces? 1, 2, 3, 4. And then I must remember that the frictional force is there. So meaning I am going to have the Fk, which is the kinetic frictional force. Kinetic frictional force is the force that opposes the motion of an object. So my beautiful learners, I just want to show you something. More often when you are using this type of when you are having frictional force in this fashion, this type of frictional force is not going to assist you, more especially when you perform the calculations. So many learners are saying that from this diagram they will be saying that they are having only 3 forces that are acting parallel to the surface, and then that is wrong, because of obviously this Fg, if we had to resolve that Fg into components, we will be in a position of having Fg perpendicular and Fg parallel. So obviously when those 2 forces are visible, we will then realize that the forces that are acting parallel to the surface are no longer 3, but we are having 4. So let me show you. Instead of throwing my Fg in this situation, I can just throw my Fg into components, meaning here I'll be having Fg perpendicular, which is equivalent to mg cos theta. Please, my beautiful learners. And then I will also be in position of having Fg parallel, which is equivalent to mg sin theta. So meaning when your teacher at school is marking you, you'll be getting 1 mark for drawing Fa, 1 mark for drawing normal force, which is always perpendicular to the surface, 1 mark for drawing tension, 1 mark for showing the Fk, which is the kinetic frictional force, and then 1 mark for showing Fg or the components, meaning there is only 1 mark allocated for both component, Fg parallel and Fg perpendicular. So my beautiful learners, what I normally tell you is that it is very simple to draw a free body diagram without components, but it is very important for you to know how to use or how to draw the components, because of when you draw the components are the one that you are going to use more especially when we perform the calculations. Okay, so 5 marks for that one. So now let us go to 4.1.2. 4.1.2 state Newton's second law of motion in weights. My beautiful learners, when you state the law or when you define the terms, please make sure that you get the definition or the laws from the examination guideline. Please, my beautiful learners, I know that you are creative, but now we don't want your creativity. We need you to go to the examination guideline and get the definition according to the way it appears from our examination guideline. I know, my beautiful learners, I know that you are laughing, and then I'm not laughing, I'm very serious. Please do make sure that you get your definition from the examination guideline. So from the examination guideline, the Newton's second law of motion is as follows. When the net force act on the object will accelerate in the direction of the net force at an acceleration directly proportional to the net force and inversely proportional to the mass of an object. Okay, when the net force acts on an object, the object will accelerate in the direction of the net force, and an acceleration is directly proportional to the net force and inversely proportional to the mass of an object. So my beautiful learners, please go to the go to your examination guideline to verify it, because I want you guys to get more marks on this topic so that you are one step out of poverty. Okay, so now 4.1.3, calculate the magnitude of tension in the string connecting the blocks. My beautiful learners, actually when we calculate the tension or when we calculate the acceleration, we have two methods that we can use. We have the system method, and then we are also having the simultaneous method. Each and every time when you use the system method, if the question is out of 6 or 7 or 5, you will get half marks. So I will advise you, my beautiful learners, each and every time when you are asked this type of question, please develop your mathematics by making sure that you go the route of simultaneous. It is quite simple. Let me show you. At least now we do have the free body diagram for 1 kg. This free body diagram is for 1 kg. Let me draw the free body diagram before I can attempt this question. Let me draw the free body diagram for 2 kg. Let me use this space here. For 2 kg, let me draw the free body diagram. Here is my surface. And then I'm just going to draw my object on the same line as my surface. And then I can see that here I'm having the tension. The tension is the one that is pulling 2 kg upwards. The tension is the one that is pulling 2 kg upwards, meaning this side I'm having T. My beautiful learners, remember that the magnitude of tension, this tension and this tension, they are equal, but they are acting in opposite what direction, meaning the magnitude of this tension is equals to the magnitude of this tension. In this diagram, the magnitude of tension will be negative, but in this diagram, the magnitude of tension will be positive. Okay, and then what else do I have? I do have the normal force. I know that the normal force must always be acting in or perpendicular to the surface, and then I must also be in a position of having FG perpendicular, FG parallel, I'm sorry, and then kinetic frictional force. Kinetic frictional force. So here are the forces that I'm having. How many forces are here? 1, 2, 3. But for this one, 1, 2, 3, 4. Okay, now let me show you. We are required to calculate the magnitude of tension. I do have a tension on this diagram, and I also have a tension on this diagram. The first step that I must do, I must make sure that I get the magnitude of acceleration of the system. And then the very same acceleration of the system, I will substitute it either to equation 1 or equation 2 so that I can get the magnitude of the tension. So now let me show you. It is quite simple, my beautiful learners. I'm just going to say for 1 kg, F net is equals to MA. How many forces are acting horizontally or parallel to the surface? I have about 4. It's 1, 2, 3, 4. So I'm going to have F applied minus FG parallel minus FK minus tension is equals to MA. So now, what is the value of FA? The value of FA is 30 newtons. So here I'm going to put 30 minus. What is the value of MG? FG. The value of FG parallel, as I've said earlier, FG parallel is mg sin theta. Mg sin theta. So let me do it somewhere here. FG parallel is equals to mg sin theta. What is the value of mass? The mass for 1 kg is 1 multiplied by 9,8 sine. What is our angle? The angle that is given is 28. So now let me press my calculator. I'm going to have 1 multiplied by 9,8 sine 28, and then the value that I get there, is 4,6 newtons. 4,6 newton. So meaning the value here is 4,6 minus the FK for 1 kg block is given on our statement. The kinetic frictional force between the 1 kg block and the inclined plane is 4 newton. Meaning in the position of FK for 1 kg block, I'm just going to put 4, and then minus T is equals to 1 multiplied by our acceleration. We don't know what is the value of acceleration. So my beautiful learners, as you can see, 30 is the only force that is positive. Why positive? Because it's the only force that is doing a positive work, more especially when we get to work energy and power. It's the force that is pulling the system up. It's the only force that is moving up. So that is why when I substitute it here, the magnitude of FA is the one that is what? That is positive. But the rest of the forces, our T is negative, our FG parallel is negative, our frictional force, they are negative. Why are they negative? Because they are acting in opposite direction to the motion of our object. So for now, let us put everything on our calculator. So I'm going to have 30 minus 4,6 minus 4, and then it gives us 21,4 minus T is equals to A. Is equals to A. And then now let me make T subject of the formula. Let me transpose T to this side and then take A to this side. And then I'm going to have 21,4 minus A is equals to T. Is equals to T. This is my equation number 1. This is my equation number 1. So now let me go to 2 kg block. For 2 kg block, the procedure is going to be the same. But now I want us to focus on this diagram. The same procedure, my beautiful learners. F net is equals to MA. How many forces are acting parallel to the surface? I'm having about 3 forces. As you can see, T now is moving upwards, meaning T is going to be positive because of it's the one that is pulling 2 kg block upwards, and then our FK and our weight parallel, they will be negative. Okay, so I'm going to have T minus FK minus FG parallel is equals to MA. Okay, so now what is the value of T? We don't know. So T minus, for 2 kg block, we are given the kinetic frictional force between the 2 kg block and the incline is what? Is 8 Newton. So meaning here I'm going to minus 8 minus the FG parallel. One thing that I know, the FG parallel is equals to mg sine theta. What is our mass? Our mass is 2 multiplied by 9,8 sine our angle that is given is 28. And then now let me put everything on my calculator. So 2 multiplied by 9,8 sine 28, and then my answer there is 9,20 newtons. So meaning in the position of FK, let me put 9,20 is equals to 2A. So I want to make T subject of the formula. So now negative 8 minus 9,20, it gives me T minus 17,2 is equals to 2A. Okay, so now guys, let me make T subject of the formula. So T is equals to 2A. When I transpose negative 17,2 to the other side, it's going to change the sign to positive 17,2. This is my equation number 2. So now, my beautiful learners, please listen to this one. This T is our tension, but for now, in order for you guys to make you understand, this T, let us say maybe it represent Mr. Tshaka. This is Mr. Tshaka, T. This T, Mr. Tshaka, is equivalent to let me just say that the Tshaka is equivalent to James. That is number 1. That the Tshaka is equivalent to James. That is number 1. And then number 2, this T also it represent that the Tshaka. That the Tshaka is equivalent to Lerato. Meaning Lerato and James are also equivalent, because Lerato and James are equivalent to Ndate Tshaka. So meaning, my beautiful learners, T is equal to 21,4 minus A. And then even here, T is equal to 2A plus 17,2. That simply means 2A plus 17,2 is equal to 21,4 minus A. Why am I saying that? Because both equations are equal. Both 21,4 minus A and 2A plus 17,2, they are both equals to T. So for now, this is what I'm going to do. So 21,4 minus A is equals to 2A plus 17, 2. So for now, we are in a position of calculating the value of A. So in order for me to calculate the value of A, let me just say, let me transpose 17, 2 to this side. So I'm going to have 21, 4 minus 17, 2, which is equals to 2A. If I take this minus A to the other side, it is going to be positive. So now 21, 4 minus 17, 2. Our answer there is 4, 2, which is equals to 2A plus 1A. 2 plus 1 is 3 what? A. So from here, my beautiful learners, we must divide both sides by what? By A. By 3. We must divide both sides by what? By 3. 3 cancel 3, and then we are left with A is equals to, let us press our calculator, 4, 2 divided by 3. 4, 2 divided by 3, my answer is 1, 4 meters per second squared. This is my acceleration. But remember, the question says that we must determine the magnitude of the tension. So with the acceleration that I have, that I got here, I must choose if whether I'm using equation 1 or equation 2 to solve for the tension. So let me take equation 1. Equation 1, it says T is equals to 21, 4 minus A. So I'm going to have 21, 4 minus, the value of A is 1, 4. So now when I press my calculator, 21, 4 minus 1, 4, our answer there is 20 newtons. Is 20 newtons. Okay, so now let's check, what about equation 2? If I substitute my acceleration on equation 2, I'm going to say T is equals to 2A plus 17, 2. So what is my A? The value of A is 1, 4 plus 17, 2. So if now I press my calculator, the value that I get there is still the same as 20 newtons. 20 newtons. So my beautiful learners, this is question 4.1.3 for 5 marks. This is the procedure that you must follow in order for you to get 5 marks. Let me share this thing with you. Physical science is not difficult. The work in physical science is more. If you really want to get your level 7 in physical science, please make sure that you put more effort. Please make sure that you do as many exercises as possible. And then I do believe that the more you do the questions, the better you will get the results. So if you really want to get the good results, my beautiful learners, please do make sure that you put more effort on your schoolwork.